Hello, this is the next lecture from where I left off yesterday. You remember there were two things, one is from the Remsburg book and another is from our own Professor Schoenholzer's notes, and a little bit of saying what will happen in case you have a contact resistance problem. So, if you can kindly look at the sample which I have given there. Some of you, not some of you, if you just go back, you may recollect this is taken from a commercial controller, and I think some of you will know, and then this is not damaged due to our product design requirements, and to be connected to a big bus bar like thing, they had to bend this lead a little. The beauty of this is whatever they talk about at the back, you have seen this. We have a solid plate, and in general, in principle, we are not supposed to alter it or what do you call try to do it. And then here comes the thing, what do we do about this surface? Do we keep it as it is, or do we, how do we cool it, or whatever it is? This is where all our two levels of analysis is required. One of them is, if you see, this heat sink has been made for fan cooling of devices which are mounted on this surface. And then we also have a fan here which, as I have told you earlier, which approximately covers these areas, and then we have this. But then you will notice here is, if you are starting a design and you have control over the various spaces, maybe you can always use it, and then we always have a long length, and then you decide using little bit of empiricism, a little bit of handbook and supplier's catalog, because what you wanted to do probably he has done it himself. Seen that, no? You seen the beautiful cross section. This was I was trying to tell you, and you see the way the fins are tapered to improve the fin effectiveness. And then if you worry about all the other things, no, not worry, if you consider all the other things, saying I have a fan here and then why not make it deeper and all that, the consideration about there being deeper or spacing, you have only so much control, not infinite control as you would do for an analytical thing. These things, it is a compromise between how much space is available for your full module and then what all you have to mount here, and then in this case actually it has been removed from where 3 TO3 packages were mounted here, and this was checked for that purpose, saying if you just mount it as it is in the fins vertical direction, how does it work? Later on, can we add a fan directly, and what is the effect of this? If you have a thing like this, typically what is the effect? And in the case of regular what you call product design, we have this beauty of, we will be able to, well, I will not call it strictly firefighting, upfront I can try to add one more device to improve the or force the circulation. This again I would like to what do you call play a little on your memory, saying a little bit of experimentation, a lot of theory, and you next decide how much of spacing, how long or big can it be. Okay. Here the manufacturers would have done whatever data you want to make, and then you make sure that you have a tube like thing, a long tube like thing. Typically, if you are to have an industrial panel rack, this is not the 19-inch rack which you talk about, these are all the panels which are directly built. They have slightly different dimensions, they are not meant for directly mounting. This is a little like the relay panels and all which you find on what do you call in your CNC machines. So, what they do is fan, one of the places fan, and then in between heat sink, and something to do with the heat sink, the length of the heat sink. Now, once again, because of the plethora of devices that is available, we need to start working on these things. Not every time that we are actually starting from scratch and doing things. So, I will now point out to a practical thing. This is, as I said, it is a drive which was purchased to be used in a what you call hybrid three-wheeler, can be used for as an auto rickshaw. In our places we call it an auto rickshaw, or it can be used in any invalid carriage having more than 3 wheels. Now, having searched around, our people could locate a nice cute heat sink. Okay, it is heavy, and the only what you call good point of it is, you see, somehow it seems to miraculously match, and you have enough place for mounting. You have place for mounting holes, 2 of them here, and then 2 plus mounting holes here. Now comes to the same thing. What are the purpose of the mounting holes and what to do with this heat sink, and what do you do about the imperfections in this? So, I have a surface, you have a surface, you have a surface, and what all you have spoken about saying keep the surface at a temperature, keep the surface at temperature, still tremendously depends upon the resistance and the air gaps and the contact that is made. You have hills and valleys, then you have a RMS value of the roughness, and then when you mount one over the other, how well they behave. This is all related to that. Just for say, I could not cover it in the last time because to prevent the flow, though the things are available. Right now, I will take it away from here and then get back to have a look at this paper I could retrieve. Most important you will notice is, you see this at the bottom. Beauty, see when it was made. It is about the time when I started my professional career, 45 years back. I did not make it, but I could retrieve it from the what you call things which have been I am not able to, it did not get scanned. Anyway, so these people, they were the sort of pioneers who worked on solving these problems long ago. And when first the what you call telecommunication equipment and all came, I had the honor of working with one of the government agency which I have here, and the first rural automatic exchange rack, we try to do this analysis. I will see if I can retrieve it and see what best it is. Now, coming back, I want you to have a look at the very early on, people have tried to use CAD to thermal evaluation of closed cabinets, such are used in types of electronic equipment. I am just reading it along, and as I say, if my accented this thing is a little problem, you always have the mute button, and then you can read it on, and then luckily for us, because it is a video lecture, we can continue to measurements on a cabinet prototype used to house mobile radio telephone equipment. So, the what we see here saying the so called mobile phones or cell phones probably are much later. These things are all developed during the era of luxurious car phone system. Only the very rich could have a telephone. Alternatively, all the law enforcement and police always had it, and probably this was tried in one of those things. So, just read it along with me. Read the first part. See this, one of the thing is enclosures where cooling is performed by conduction, radiation, and natural convection are investigated. Coming back to a little this thing, not long ago fans and what do you call forced cooling was not considered really that great a what do you call approach to make things easy. One of the first things is, what if something fails and we want things to work, and then at that time there was not this mad what do you call tremendous of hotness around. See, in this electrical analog for the cabinet is postulated and the components of this model are calculated. Network is analyzed on a digital computer using electronic circuit analysis programs for DC and transient analysis. See that DC is represented by simple potential and resistances by normal what you call heat transfer coefficient. Transient analysis is wherever heat storage can occur, as in the mass and the density of the material. Just to make this paper complete, electric analogy will be using is obtained by replacing transmission line by lumped approximation, replacing partial differential equations with finite differences. We describe only the approximations for conduction, convection, radiation, which all have direct bearing upon the problem at hand, namely temperature distribution in closed cabinets. At the end, references are given. I could not what do you call exactly get the references. So, you go by here, this I have already covered to you yesterday. Everywhere we have somehow you need to calculate this K, and eventually you can make a thermal conductance as 1 by R, or R is the thermal resistance. Having all this from here, it is very very easy for us to go about making this. I think we have repeated again and again. Now, seen this. Temperature distribution can be found by computing or measuring the nodal voltages in electrical analog of the cabinet. So, equation 2, one of the first assumptions is heat flow is in a homogeneous medium. You have seen this here, this is what I wanted to show you. Thermal contact resistance of such surfaces will contribute significantly to the heat resistance. So, coming back to my model, easy, manufacturer has made this, and I will not say he has what do you call, he has made specified certain conditions saying if the outer surface of the plate can be maintained at typically around 30 or 40 degrees centigrade. From there he has given that thing saying typically we can get 3 degrees centigrade per watt or 2 degrees centigrade per watt directly all the way inside. Now comes the question, even this manufacturer has mentioned saying this heat spreader has a nicely computed this thing and measured and all that, and then he has used all the, you have seen that you can probably see a little about the grooves that are cut on it. And see, one more small thing you can notice is they are tapered and base is very thick. If you take the total area of it, and then the fact is that there is a large gap here, there is a gap here, it is a little thick here, and this whole thing is there. Generally such a construction, when you have tapered fins and then you have a strong depth and all that, probably refers directly to a heat sink that can be used in forced convection. Now, having known this data, we have happily one on top of the other, and then I will find a way of how to clamp this and maybe put a flange or take the next higher size. Imagine this can be brought here, I can take the next higher size, drill holes, match and drill holes, and put another plate which is what do you call, which can distribute the load here, and then either tap this whole thing and then insert what are called helicoil inserts. Helicoil is nothing but a helix with a diamond shaped spring which sits in these soft materials. So, if you have a helicoil insert here, one insert here, one insert here, I can now use probably a hexagonal or some other headed screw on the other side, tighten it and hope things fall into place, because in spite of my best understanding of the situation, we still have, you have seen this nicely, it is rotating here. So, that shows they are not in that much in a perfect contact. Same thing here, this is slightly better. So, I try to apply some heat sink compound and try to apply as much pressure as possible. This is exactly what the Jensen has was talking about. Contact resistance of such surfaces will contribute significantly to the total heat resistance. This is where strictly adhering to specified physical mechanical parameters like the RA, the what you call root mean square average of the what you call pits and valleys, and also how well you protect it, and even movement between the fabrication shop and this. You have seen this, just read it for yourself a little louder. So, you have read if a horse could ride, this is exactly from the horse's mouth. A lot depends on the contact resistance, which in turn depends on the pressure. And that is where what I was talking to you about, how strictly you can, how well you can clamp the thing. And if you use too much of a thing, the chances are too much of pressure, chances are one of the plates will give, that will create a problem. Further down we come to the other thing. You have seen that once for the first time we are ending up thermal capacitance of the medium, density, specific heat, and the volume that is involved in various things that we have here. Corresponds to the electrical relationship. One more, if somehow we can lump the whole thing to an equivalent electrical capacitance, we can directly use it. Now, it will come back to the good old question, and then especially two types of people are very curious. One of them is students are working towards their some thesis and practical work, secondly practicing engineers saying is that somewhere I get this data. My considered opinion not readily available, you need to approximate, take something which is about near as equivalent and check. So, this is exactly what these people have also done, and in the end they have reported the results. Now, we have all this transfer radiation, I mean you can read it. Oh, sorry for the little bit of jumping, and I am not used to these things. There is no correlation between optical color and emissivity. So, when I talk to you about this thing, sorry for repeating, it really does not matter. So, if you go to the web and check on all the practicing, I will say, I will use the word hacker without the bad name. Hacker is, not long ago, at least in our time, no, it meant somebody who will mess up with trying to find things out. It is not jailbreaking, it is not trying to create malware and so on. It is about trying to understand, which I am sure some of you curious would have tried it. So, if somebody says black is better than white, as I said, if he is a teacher who has to grade you, whatever he told you, repeat it. But then the original is it does not make any difference. Between two surfaces A1 at T1 and the A2 at T2, we have this beautiful thing in which we again end up with temperature factor, another what do you call saying, is there something we can use directly, and after if you take these various temperatures and so on, no, is approximately constant in a broad temperature range, thereby justifying a linear dependence of heat flow upon temperature difference as suggested by the earlier equation. Radiation factor is a definition of a function of the surface properties and of their geometries. Following situations are relevant. Completely enclosed by the surface, it is approximately equal to this. Computing radiation from cabinet surfaces to their environment, two parallel planes with the distance between the planes in comparison with the length and width of the plates, we have all this, may be used for taking into account internal radiation in the equipment. Is the radiation constant for a black body, it is equal to the Stefan Boltzmann constant, and C1 and C2 a constant for surfaces, they are related to the emissivities and so on. So, finally, using all this, we have simplified things as much as possible. Now, let me go back to the next page. Next page shows you after going towards the conduction, after finishing conduction and radiation, we come to the convection. The same way, we shall consider only natural, the heat flow is due to natural this thing which you have come across last time. A is the heat generating surface and alpha is the heat transfer coefficient, dependent upon a number of factors such as the viscosity and density of the surrounding air, geometry and arrangement of the surfaces. Rigorous treatment of heat convection may be found in the literature, but the following simplified formula for the heat transfer coefficient should be adequate majority of situations. This is what Schoenhauser also has talked about. You read it for yourself again. If you remember, I had shown you something which was 0.6, 1.3, 1.6. So, he has from somewhere else, he has got these figures saying if a horizontal surface is facing upwards, surface facing downwards, and if the vertical surface of height is so much, for a vertical surface I have stuff things so much and all this. So, depending on which are the places when you can compare, saying the bottom surface of the cooling and top surface of the cooling and so on, you can apply these things, but all of it depends again once again on your specific condition, and then how do you try to get into this. In the case of radiation, heat transfer by convection is in reality nonlinear. The constant value for alpha inserted gives a linear approximation. A guess must be made the difference before the heat transfer coefficient can be computed. If necessary, new more exact value may be used based on the final results of the first approximation. You have seen this. So, all the people who actually wrote the books, they all talk about there is no one shot way of solving anything. You need to probably, it is a little like your Newtonian methods of trying to find a root. You have to start with the initial root, find the difference and keep working back onwards. For a new exact value may be used based on the final result of the approximation based on the computed cabinet temperatures. And then here we get a very difficult or forced empiricism on it. And here he has written saying contributions from radiation and convection to the heat transfer are often equal. So, I contest it and you can prove either him or me right. Have a look at the picture, try to understand what the picture can be saying.